Good morning, Chem 151 students or classmates and Professor John Savage. This is Benjamin Kidd here, and I'm going to be presenting you guys the empirical and molecular formulas. This example right here is a compound is composed of 52.14% carbon, 13.13% hydrogen, and 34.73% oxygen by mass. Letter A is what is the empirical formula, and B is if the molar mass of the compound is 138.204 grams per mole, what is the molecular formula? And of course, right here, what you want to do first is change the percent of, the elements to mass, to the mass of their elements, like putting the G there for grams. Like, for example, right here, we're going to do this first. So, 52.14% of carbon, although actually, like I said, you change that to G, so you want to change that to G of carbon, and you want to multiply it by 1 mole, of course, on top of C. But then what it's going to be canceled by is on the bottom, it is going to be the molecular weight of carbon, and that is 12.01 grams of C. And when you convert that, according to our calculation, when you convert that, it equals to 4.341, and the reason, of course, so it's, I'm sorry, it's not 3, excuse me. I meant to put 4 first, but it is 4.341, if I'm, and the reason that's the case is because of its 4 significant figures. That's how we put it. All right, let's do 13.13 grams of H. You got to times that, of course, by, and it's going to be canceled by the molecular weight of hydrogen, and that is 1.00, I believe it's 8, 0.8, and of course it's 1 mole of H, and if you combine that in the calculation, it will turn out to be 13.03. And of course, once again, this is 4 significance figures, so this is 13.03. And so, of course, we're now going to do oxygen, and that is 34.73%, G of O, times, and then here's what we do. On the bottom here, we're going to be putting the molecular weight, and of course that's 16.0 grams of oxygen, and this is 1 mole of O. And when we put that in the calculator right here, I'm looking at my calculator, that would be 2.171. So 2.171, and of course, once again, that is the 4 significant figures. So what we got to do now to find the empirical formula first is that we have to always divide by the least amount of number we have. For example, out of all these numbers, 2.171, is the least amount of numbers that we have. So we're going to divide this by 2.171, and we do it to the same amount of numbers. And so, consider we are, after we do it to the same amount of numbers, we can obviously say that because O has the same numbers, of course, O is going to be equal to 1. All right, and then for 4.341 divided by 2.171, if we put that in the calculator, I think we get, so we'll do this, so 4.341 divided by 2.171, that would be, all right, that would equal to 1.999, but that actually equals to 2 because it rounds up to 2. So it's 2 grams of carbon, and now we're going to be putting 13.03 divided by 2.171. What do we got? And that equals to 6. So we got 2, 6, and 1. So what that means is empirical formula is, all right, that means it is C2, H6, and O. You can even add a 1 there if you like, but sometimes people don't add the 1, and that will be the O. So that is the empirical formula. However, we are not done yet, because on letter B, we did just finish A, so we can check that off. And then B, we just got to find the molar mass, of course. We got to find the molecular formula, and it gives us the grams per mole. So what we got to do now is define what would equal, or how many, of course, in that mole. So 138.204. And what we're going to do is basically, we are going to do 2 times 12.01. And the reason we do that, of course, is because that represents the carbon. We do the carbon element first, and we add it by hydrogen, which is 6, of course, times 1.008. And then that is, of course, we have to add, and then we plus 16, right? And then when we get that, all that together equals 46.068. And of course, we have to put that equals 138.204. And of course, now we have to divide by 46.068. And of course, we now divide. And when you divide this according to the calculation, it equals to actually 3. And there you go. We got the 3 here. So now that we have the 3 here, now what we have to do is times the numbers in the empirical formula by 3. So here we do C2 times 3, and then H 6 times 3, and then O 1 times 3. And all that equals C6, H18, and then O3. Now that right there, guys, ladies and gentlemen, is the molecular formula of CHO. What the difference is here is the empirical formula is like the 1-to-1 ratio. Molecular formula is almost like a double. It's almost like a double ratio version of empirical formula, you should say. It really depends on how many number we have, or how much number you have. But what we did was times the empirical formula by 3, and that is what we get. And this is the entire problem-solving equation to the example that I have. Thank you, everybody. Hope you enjoy watching this video, and I hope you guys have a good day or good night.